What is up, everyone? So today we're going to be diving back into Reactor and talking about subtractive synthesis. So, if you don't know what subtractive synthesis is, I'm just going to break it down for you over this session, um, give you a short definition of what that is. So, so I'm DannyXander. Welcome to the session, and today we're going to be talking about Reactor and using sound design tools to create subtractive synthesis. Here I have open Reactor, which is a sound design synthesis tool that we use to shape sounds for film, TV, and video games, or for music production. So, in terms of sound design, when we have subtractive synth, we can use a variety of waveforms, and those can be a pulse, a sine wave. We can use a triangle wave. We can use a square wave, and permutations in between that of different kind of waveforms that we can use. So the more harmonically rich waveforms that we have are usually our sine, our saw wave, and our pulse or square wave, because there's many different turns or bends, if you want to call it, in the waveform. So that would be our pulse or square and our saw, which is that one. That's our saw. So once our sound travels through our oscillator, we want to go to a filter. So a filter does exactly what it says it does. It filters out the unwanted frequencies that we don't want present in our sound. So those are upper harmonics that we want to delete or remove from what the final product is heard. So we can give this a play and hear what it sounds like unfiltered. And if we turn our cutoff on our filter, you can hear it sweeping through and cutting off the higher frequencies. The reason why it's doing that is because it's set to low pass, which means low shall pass. If we set it on high pass, it's going to cut off the low frequencies, and therefore only allow the high frequencies to cut through. So, with that being said, we can dive deeper into subtractive synthesis and really manipulate our sounds with a filter and also with our ADSR attack. So we're going to add in an ADSR envelope, which allows us to manipulate our synthesizer, and we can manipulate the attack, decay, sustain, and release stages of our amplifier, again allowing us more control over our synthesizer or our modular rack. So I'm just going to organize this a little bit better. And when we turn up our modulation depth, turn up our attack so it's slower, we can see that it affects our amplitude and how fast the sound is implemented and how fast it comes in. We can add one more element here, and that's an LFO, and we can use that to manipulate or modulate our oscillator frequency. So we're going to add that to our oscillator, and that's going to modulate our pitch of our oscillator or whatever other parameter we want to. So this is the positive signal, negative signal, the waveform going up and down. We can visualize that too as well by looking at our oscilloscope. And I can bring one of those up so we can see what's coming out of the LFO. So we can see that out of the LFO, we're getting up and down waveforms. We just saw one come through. Let's just see. There we go. So you can see the LFO is modulating at a certain rate Right now that happens to be 0.50 hertz or 0. And as you increase the LFO rate, you can see that this modulation increases the speed. So I'm going to remove that, and we're going to turn our modulation depth on our oscillator, and we're going to see how that works in action. Just going to try it on the actual wave shape. So you can see our wave shape is modulating over time. If we put our oscilloscope on the end, we can actually visualize that. So it's going up and down, and modulating between a triangle wave and whatever the waveform is that's next above it. In this case, it would probably be some sort of saw between a saw and a triangle. So right now, we can go back to a saw, and it will modulate somewhere between a saw and a triangle. It's approximate because every sound we create is going to be different. So every time we do it, it's going to be a little different. You can change the depth, the speed. And we can also change our LFO shape. So the waveform that it's using to modulate between. We can change the direction as well. Make it unipolar or bipolar, which means up and down. Unipolar. And bipolar means just one direction, which is down. So that's our. There we go. That's our unipolar and bipolar. You can see it's only going down. And you'll see it's going up and down. Up, down, up, down. So these are more advanced concepts in sound design, but I want to give you an overview of how subtractive synthesis works overall. And in another session, we'll be experimenting with different sounds and in use cases of different productions. And yeah, let me know in the comments what else you want to see over time, and I'll try to squeeze them in. For now, keep creating and stay creative. Feel free to copy this patch and work with it and see what else you can come up with and how you understand subtractive synthesis. Until next time, peace out and keep creating.